Chemistry influences feelings and love through a complex interplay of hormones and neurotransmitters that act on the brain, creating the sensations and emotions associated with love and affection. Neurotransmitters and early stages of love. During the initial stages of romantic attraction, the brain releases a cocktail of neurotransmitters, including dopamine, norepinephrine, and serotonin. Dopamine, often associated with the brain's reward circuit, contributes to feelings of pleasure and euphoria, making us feel good when we are around the object of our affection. Norepinephrine increases heart rate and energy, leading to excitement and a state of alertness, while serotonin levels can fluctuate, contributing to the obsessive thoughts often associated with new love. Hormones and deepening love. As attraction transitions into a deeper connection and attachment, different hormones, primarily oxytocin and vasopressin, come into play. Oxytocin, dubbed the cuddle hormone, is released during physical touch and intimacy, fostering a sense of closeness and bonding. It plays a crucial role in strengthening the emotional bond between partners, promoting feelings of love and trust. Vasopressin is associated with behaviors that produce long-term, committed relationships, contributing to the development of mutual attachment and monogamy. The brain's reward system. Love activates the brain's reward system in a manner similar to the way it responds to pleasurable stimuli or addictive substances. This activation is why being in love can feel so rewarding and why the loss of love can feel so distressing. The brain's reward centers are flooded with dopamine when we experience love, reinforcing the desire to maintain the emotional and physical connection with our partner. Stress response in love. Experiencing love also affects the body's stress response system. Initially, love can increase cortisol levels, a stress hormone, reflecting the anxiety and nervousness often felt in new relationships. Over time, however, being in a stable and loving relationship can lower stress and cortisol levels, contributing to better overall health and well-being. Chemistry influences feelings and love through the release of specific hormones and neurotransmitters that affect how we feel, think, and behave when we are attracted to someone, forming deep emotional bonds or experiencing the loss of love. This biochemical foundation explains why love is such a powerful, universal emotion that can deeply affect our mental and physical state. It's a journey into the depths of the human mind and heart, uncovering the intricate workings of our innermost feelings and desires. So fasten your seatbelts as we dive into the captivating world of love, exploring its many facets and unraveling the mysteries that lie within. Love is more than just a feeling. It has a basis in our biology. This statement might sound surprising, but when we discuss the intricacies of the human brain, it's clear that love is a complex interplay of biology and emotions. Let's begin with the brain, the epicenter of all our feelings and emotions, including love. Certain regions of the brain play a critical role in the experience of love. At the forefront is the limbic system, often referred to as our emotional brain. This system, made up of structures such as the amygdala and hippocampus, is essential for our ability to feel and express love. It processes emotions, regulates emotional responses, and forms emotional memories. When we experience love, our limbic system is hard at work, interpreting these intense emotions and creating memories that can last a lifetime. Another key player in the biology of love is the reward center of the brain, which includes areas like the ventral tegmental area and the nucleus accumbens. This center is a hub for our feelings of pleasure, desire, and motivation. When we fall in love, this reward center lights up, releasing a flood of feel-good chemicals like dopamine. It's the same area that activates when we enjoy a delicious meal or achieve a significant goal. In essence, our brain rewards us for falling in love, making the experience feel exciting and fulfilling. Now let's consider the hypothalamus, a small but mighty part of the brain that has a big job when it comes to love. It oversees the release of hormones like oxytocin and vasopressin, often referred to as the love hormones. These hormones not only deepen our feelings of attachment but also play a crucial role in long-term commitment and monogamous relationships. In the grand scheme of things, love is a symphony, with different parts of our brain and body playing together in harmony. Each component plays its role, contributing to the beautiful, complex, and sometimes perplexing experience of love. Thus, the feeling of love engages some of the most complex structures within our brain. Did you know there are specific chemicals that fuel the feeling of love? Let's discuss the science behind these emotions. When we talk about love, we can't ignore phenylethylamine, often called the love drug. This amphetamine-like compound is responsible for that initial heady rush of infatuation, the butterflies in your stomach when you see someone you're attracted to. It's like an emotional roller coaster, exciting and a little nerve-wracking. Then we have dopamine, our pleasure chemical. Dopamine and love are a match made in heaven. It's the reason why love feels euphoric, why you can't seem to get enough of it, and why sometimes it can feel like an addiction. Whether it's a stolen kiss, a shared joke, or a heartfelt conversation, your brain rewards these moments with a surge of dopamine, making you crave. Create the complex and beautiful experience of love. It's a reminder that love is more than just a feeling. It's a physiological process, a symphony of hormones and neurotransmitters, all working in perfect harmony. But remember, as powerful as these chemicals are, they are not the whole story of love. They are just the fuel, the spark. Love, in all its myriad forms, is a combination of biology, psychology, experience, and, perhaps most importantly, choice. These chemicals work in tandem to create the unique cocktail of sensations we recognize as love. Love evolves in stages. This isn't just a poetic sentiment, but a scientifically backed idea, thanks to the work of Dr. Helen Fisher. She proposed a theory that love evolves through 3 stages: lust, attraction, and attachment. Each stage is characterized by its own unique cocktail of brain chemicals, contributing to the different emotions and behaviors we associate with falling in and staying in love. Let's start with the first stage, lust. This is the initial spark, the physical desire driven primarily by the hormones testosterone and estrogen. These hormones kickstart the process of attraction, acting as the biological counterpart to the proverbial Cupid's arrow. Next, we move to the attraction stage. This is where the heart-racing, exhilarating part of love comes into play, and it's largely thanks to a trio of neurotransmitters: phenylethylamine or PEA, dopamine, and norepinephrine. PE, often known as the love drug, creates feelings of euphoria and excitement. Dopamine, the pleasure chemical, contributes to the sense of happiness and satisfaction. Norepinephrine, on the other hand, is responsible for the adrenaline rush, causing the racing heart and the excitement. The final stage, attachment, is the deep bond that keeps couples together long enough for them to have and raise children. Oxytocin, the cuddle hormone, and vasopressin play vital roles in this stage. Oxytocin deepens feelings of attachment and promotes trust, while vasopressin is crucial for long-term commitment and monogamous relationships. What's fascinating about this is that our brain has the ability to juggle these different chemicals at the different stages, sometimes even simultaneously. One might be in the lust stage with one person, in the attraction stage with another, and in the attachment stage with yet another person. It's a complex, beautiful dance of neurochemistry that shapes our experiences of love. Love, therefore, is not a static phenomenon. It evolves and transforms over time. And with each stage, our brain chemistry adjusts, creating a unique symphony of emotions and behaviors that we recognize as the journey of love. Our genes can influence our experience of love. Love, it seems, isn't just about the fluttering butterflies in our stomach or the quickening of our heartbeat. There's a more profound, intricate aspect to it: our genetics. Ever wondered why we're attracted to certain people and not others? It's not just about their looks or personality. Our genes play a significant role too. Let's take a closer look at the major histocompatibility complex, or MHC. This group of genes is crucial for our immune system to recognize foreign substances. Fascinatingly, research suggests that we might be attracted to people with a different MHC to ours. Why? It's all about survival. A diverse MHC means a broader defense against diseases, a significant advantage for potential offspring. But it's not just about partner selection. Our genes can also influence how we experience love and attachment. For instance, variations in the oxytocin receptor gene, known as OXTR, have been linked to differences in social behavior and bonding. Some variants of OXTR might make us more empathetic and nurturing, while others could make us more prone to anxiety in relationships. And it's not just oxytocin. Other genes, like those involved in the production of serotonin, a neurotransmitter involved in mood regulation, can also impact how we experience love. Variations in these genes can influence how intensely we feel emotions, including love. However, it's important to remember that our genes are not our destiny. They merely set the stage. Our experiences, environment, and personal growth all play a part in shaping our love life. So, while we might not be able to control our genes, understanding their impact can give us a new appreciation for the complexity of love. It adds another layer to the already intricate dance of attraction, attachment, and long-term commitment. Our genes, it seems, have a say in who we fall in love with. Love can have a profound impact on our health and longevity. This isn't just a romantic notion, it's backed by scientific evidence. Longitudinal studies on the health benefits of love and stable relationships have shed light on the significant role love plays in our overall well-being. When we are in a loving relationship, we tend to have lower levels of stress hormones. This has a direct impact on our cardiovascular health. It reduces our risk of heart disease and can even lower blood pressure. It's not just about the heart, though. Love also boosts our immune function, making us less likely to fall ill. It's as if love has a protective shield around us, guarding us against various health threats. But the benefits of love extend beyond our physical health. Love contributes to our mental and emotional health as well. Being in a loving relationship can lead to increased happiness, reduced anxiety, and even better cognitive function. It's like a magic potion with the power to uplift our spirits and sharpen our minds. On the flip side, the absence of love can have serious negative impacts on our health. Heartbreak and social isolation can lead to increased stress levels, triggering a cascade of harmful effects on our body. It can lead to depression, anxiety, and other mental health issues. It can also weaken our immune system, making us more susceptible to diseases. The physiological effects of social isolation can be particularly severe. Studies have shown that prolonged loneliness can be as damaging to our health as smoking 15 cigarettes a day. Yes, you heard that right. Loneliness can be as deadly as a major health risk like smoking. In essence, love is not just a feeling or emotion. It's a powerful force that can shape our health in significant ways. It's a vital part of our lives, influencing everything from our happiness to our lifespan. The presence or absence of love in our lives can significantly influence our health and well-being. Not all love is created equal. This statement rings true not just in our experiences, but also in our biochemistry. The unique cocktail of neurochemicals released in our brain during different types of love is what sets them apart. Let's start with romantic love. When we fall head over heels for someone, our brain releases a surge of phenylethylamine, or PEA, dopamine, and norepinephrine. These chemicals create a whirlwind of emotions, making us feel euphoric, obsessed, and excited. This is why new love often feels intense and all-consuming. Now compare this to platonic love, the deep affection we feel towards our friends. While platonic love also triggers the release of dopamine, the intensity is less than that of romantic love. Serotonin plays a significant role here, promoting feelings of contentment and well-being. The bond of friendship is also strengthened by oxytocin, but its release is more gradual than in romantic love, reflecting the often slower, steadier development of these relationships. Familial love, the bond we share with our parents, siblings, and children, taps into yet another set of chemicals. Oxytocin and vasopressin are the stars here, fostering feelings of deep attachment and trust. This is why the love we feel for our family often feels stable, secure, and unconditional. So, what does this all mean? It means that our brain has a unique way of processing different types of love, each with its own chemical signature. This biochemical diversity reflects the varied roles that these relationships play in our lives, from the exciting passion of romantic love, the warm contentment of friendships, to the secure attachment of familial bonds. Each type of love enriches our lives in unique ways. Remember, love is not just an emotion. It's a complex interplay of neurochemicals that shape our feelings, our relationships, and ultimately, our lives. Each type of love has its unique biochemical signature, reflecting the different roles they play in our lives.